Hi, welcome to Pre-Calc B. This is the first video that we're going to do in Pre-Calculus B. We're going to start our trigonometry section, our unit for trig. Most of this stuff will be on the ACT test, so that's why I'm kind of going to mix around the chapters depending on what I feel is more important for you to take that ACT test. If you've already taken the ACT test, then we're just going to do this the same way we do anything else, but I'm going to try to get as much ACT information in as I can before you have to take that test in March. So the trig section is a very important thing. There's a lot of questions on the ACT about trig. So let's get right into it. So section 9.1 is where we're going to start. We're going to do chapter 9 first. This is called right triangle trig. Therefore, we're only going to be talking about right triangles for these first couple chapters, or the first couple sections. So the objective is to use trig to find unknown sides or angles of triangles. And a lot of this stuff should be reviewed from geometry. It's just a matter of remembering all about it. So let's get right into it. All right, so right triangle, and we have 6 trig functions that we need to talk about. It says let theta, this is the Greek letter theta. Theta is spelled, let me get my marker here. Theta is spelled Theta. Theta. It's a Greek letter. Let theta be an acute angle. Okay, remember acute angles are less than 90 degrees in a right triangle. The 6 trig functions of theta are defined as follows. So let's go over this triangle first. If we have a right triangle, the angle in the corner is always going to be 90. That means the other 2 have to add to 90 to make the whole 180. So right triangles have 2 acute angles. Okay? The theta always has to be one of the 2 acute angles. We can never be talking about the 90 and talking about theta. Theta is always one of the 2 acute angles. Okay? So we're going to say that this is our theta, this acute angle down in the bottom. I've labeled the triangle based on this important angle, this theta. Across from the 90, or across from theta is always the side opposite. Across from the hypotenuse, across from the 90 degree angle is the hypotenuse. And then the side that touches theta is always called the adjacent side. All right, so we have 6 trig functions that we need to look at. Now I've spelled all these out the long way. Okay, right underneath them, I will write the abbreviations. Sine is abbreviated SIN. Cosine is just cos, C-O-S. Tangent is just tan, T-A-N. Cosecant, that's a new one, is C-S-C. Secant is S-E-C. And cotangent is C-O-T. Okay? And these 6 trig function definitions are based off the right triangle for whatever angle is your theta. Okay? So for this triangle on the right, these are your trig functions. Sine is always opposite over hypotenuse, opposite over the hypotenuse. Cosine is always the adjacent over the hypotenuse. Tangent is the opposite side over the adjacent side. Cosecant is the hypotenuse over opposite, and then so on. So now, if we notice here, sine and cosecant are reciprocals of each other. So if you want to put a circle around these 2, these always go together. These are a pair. If you know the sine, you know the cosecant is the reciprocal. So opposite over hypotenuse turns into hypotenuse over opposite. Okay? Cosine goes with secant. Those 2 are paired together. They are reciprocals of each other. Adjacent over hypotenuse turns into hypotenuse over adjacent. And the likely pair down on the bottom here, which is the obvious pair, tangent and cotangent are pairs. They are reciprocals of each other. Opposite over adjacent turns into adjacent or opposite. Okay, now, if you notice here, the easy way to remember these pairs is one of the S's goes with the other C. And then the next pair, the C, goes with the S. Okay, so you'll never have 2 S's that are pairs or 2 C's. They always go with the opposite letter. Okay, and always remember the SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay, SOHCAHTOA, S-O-H-C-A-H-T-O-A. If you remember that spelling, you will know the first three trig functions, and then all you have to do is remember that the next three are just reciprocals of the other three. Okay, so let's do some examples using these trig functions. All right, example 1 says, find the 6 trig functions of theta. So I have our triangle here. I'm going to label my triangle first. Here's my theta. I'm going to circle that. That's my important angle. Across from theta is always the opposite. Across from the 90 is always the hypotenuse. And then the side next to or touching the theta is the adjacent. And that's the only side that we do not know. We're given 2 of the sides. We can figure out the third. So based on our Algebra 1 skills, how do we find our missing side? Well, hopefully you remember the very famous Pythagorean theorem, a squared plus b squared equals c squared. Remember, a and b are your 2 legs. So one of my legs is 7. So 7 squared plus b squared. We don't know our other side, but we do know the hypotenuse is 10, so 10 squared. So 49 plus b squared equals 10 squared, which is 100. I'm going to subtract 49 from both sides to get the b by itself. So b squared equals 100 minus 49, which is 51. Now I'm looking for b, not b squared, so I have to take the square root of both sides. So b is equal to square root of 51. Okay, so that means my adjacent side is square root of 51, which is okay. We're not going to use decimals. We're going to leave it square root of 51. All right. So what I'm going to do first here is I'm going to get rid of this Pythagorean theorem. If you need to go back, please rewind. And now what we're going to do is we're going to find our 6 trig functions. Okay, we have it labeled. Now the easy part is just plugging in the numbers. So let's see here. So sine. Remember, sine is opposite over hypotenuse. Opposite is 7, hypotenuse is 10. Cosine is adjacent over hypotenuse. Remember SOHCAHTOA down here, you can remember it from that. Adjacent is square root of 51. Hypotenuse is 10. Now, if we had to, you would need to reduce square root of 51, but square root of 51 cannot be reduced, so you just leave it. Okay? Tangent is opposite over adjacent. Opposite is 7, adjacent is root 51, so 7 over root 51. We'll have to go back and do something with that in a second. And now these 3 are just reciprocals of the first answers. So cosecant goes with sine, and the reciprocal would be 10 over 7. Secant is a reciprocal of cosine, which would be 10 over root 51. And then cotangent is a reciprocal of tangent, which is root 51 over 7. Okay, now, 4 of the 6 are done. We don't need to do anything else with these. 2 of the 6 are definitely not done because we have square roots in the bottom. Okay, so remember back in Algebra 2 what we did, or Pre-Calc A, what we did was we had to multiply by root 51 over 51. And what would I get here? So then you just multiply straight across. 7 times the square root of 51, and then root 51 times root 51 is 51. And there is my first one. And then I do the same thing with this one. I multiply by root 51 over root 51, and I get 10 root 51 over 51. So remember, you multiply fractions straight across. That's how I'm getting these numbers. So there are my 6 trig functions. Okay? And if any of these fractions could ever be reduced or simplified, you definitely need to do that. You can't leave it. Okay? So that's example 1. Example 2. If theta is an acute angle of a right triangle, so we don't have a triangle here, so I'm going to try to draw it. And it doesn't need to be perfect. Just draw a right triangle. And label one of your acute angles theta. It says the cosine is 3 over 5. Remember, cosine is adjacent over hypotenuse. Okay, so let's label my triangle. Let's label our triangle. Across from the theta is going to be your opposite. Across from the 90 is the hypotenuse. And then next to the theta is adjacent. Okay, so what do we know already? We already know that your adjacent is 3, because that's what cosine is. So adjacent is going to be 3. Adjacent is 3. Hypotenuse is the other one. Hypotenuse is 5. Now, what does it want? What does it want? It wants cosecant. What is cosecant? Cosecant is the reciprocal of sine, remember? So if we go back to SOHCAHTOA, it goes along with sine. If sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. Okay? So we already know what our hypotenuse is. What's our hypotenuse? It is 5. We still need to figure out the opposite. So we're going to need to figure out what this missing side is. So we go back to our trusty formula for Pythagorean theorem, and you can only use Pythagorean theorem when we're talking about right triangles. A squared plus b squared equals c squared. Our two legs are our adjacent and opposite. We already know one is 3 squared. We still don't know our other leg, which is the opposite, so we're going to leave that, and we know our hypotenuse is 5 squared. Okay, so let's see what we get here. 9 plus b squared equals 25, minus 9 on both sides. 25, take away 9 is 16. Square root both sides. B is equal to square root of 16, which is 4. So my side opposite is 4. Now, where does that go? Well, we're looking for cosecant still, and the bottom is opposite. So we just figured out that our opposite was 4. So our cosecant is 5 over 4. Okay, so draw your triangle, find the missing side, and then find the trig function that they're looking for. Okay, and you can always refer back to the second page of our notes for our 6 trig functions if you don't remember what they are. So always go back. All right, so that's example 2. Example 3. Find the value for x in the triangles below. Okay, so this is what we're going to do. We need to find x. So what you're first going to do is you're going to label your triangles. The side that's touching our theta is always going to be adjacent, and across from the 90 is always your hypotenuse. So based on SOHCAHTOA, which one of our 3 trig functions, I'll circle the 3 separate ones, which one of our 3 trig functions deals with hypotenuse and adjacent? Okay, so hopefully you can see that cosine is the one that is adjacent over hypotenuse. So we're going to set it up. Cosine of our angle, 36 degrees, is equal to adjacent, which is 6, over the hypotenuse, which is x. We don't know what that is. We're trying to figure that out. Okay, so there's a fairly easy way to figure these out. First, I'm going to turn cosine into a fraction. Okay, now, anytime we have 2 fractions and they're equal to each other, you can cross multiply. 6 times 1 is 6. Cosine of 36 times x is cosine of 36 times x. Now I need to get rid of the cosine of 36 attached to my x, so I'm going to divide by cosine of 36 on both sides. Cosine of 36 over 36 is 1, so x is equal to, and this is strictly a calculator problem, 6 divided by cosine of 36. Okay, so I'm going to go to my calculator. 6 divided by cosine of 36 divided by cosine of 36 degrees. Make sure you close your parentheses and hit enter. And it should tell you what that missing side is. The missing side is 7.42. I'm going to round to 2 decimal places. So 7.42. So if we go back up to our triangle, our missing side is 7.42. Okay, that's the first one. Let's now do the same thing for the second one. Our theta is 45 degrees. Across from theta is the opposite. Across from, now touching theta is always the adjacent. Okay, so make sure you write in here's your right angle. So the side we don't have is hypotenuse. I'm not worried about that side. I'm only worried about the 2 that they give you. So adjacent and opposite, over back to SOHCAHTOA. Sine is opposite and hypotenuse, that doesn't work. Cosine is adjacent over hypotenuse, that doesn't work. If you notice, tangent is opposite and adjacent. So opposite and adjacent. Tangent of 45 degrees equals opposite, which is x, over adjacent, which is 8. Put tan of 45 over 1, cross multiply. X times 1 is x. Tan of 45 times 8. Tan of 45 degrees times 8. Okay? Now, this one, x is already by itself, so we don't have to do any dividing or anything. So if x is already by itself, you just do what it says to do. It says tan of 45 times 8. Okay? So I'm going to get rid of what I've already done. You literally type in tan of 45 degrees times 8. Oops, make sure you close the parentheses around 45. And then times 8. You hit enter, and it should tell you what that is equal to. Okay, so x equals... Oops. So x equals 8 is my missing side. So this one just happens to be both sides are the same. They're both 8, which is okay. Now, if you had one side is 8 and the next one is like 100, 150, you know you've probably done something wrong and you should go back. But all you do is type in tangent of 45 times 8 and you get 8 as an answer. Okay? So I think this is our last example. This one's probably the biggest of the bunch. It says now to solve the following triangle. Okay? Now notice we have this labeled A, capital B, capital C, so we need to find all of our angles. And the sides across from the angles are the smaller case. So angle A is across from little a, angle B is across from little b, and angle C is across from little c. So we need to figure out 3 angles and we need to figure out 3 sides. Okay? They should already have given you 3 of the 6 pieces of information. So let's label what they've given us. Okay? If we notice, they've given us angle A is 54 degrees. They've told us that angle B is 90. They've told us that little b is 20. Okay? So, now we have to find little a, little c, and angle C. Okay? So right away, we should be able to figure out what angle C is. We already know that all triangles add up to 180 degrees. Okay, so let's use our calculator to figure out what else we know. So we know we have an angle of 54, and we know we have an angle of 90. So if we add those together, that's 144. And 180 minus 144 will give me, so let's do the math over here. So 54 plus 90 equals 144. And then 180 take away a 144 is how much? 36 degrees. So our missing angle is 36 degrees. So now we have all of our angles. So I can write this in right here, 36 degrees. Okay? So now what we need to do is we need to set up a trig function in order to find one of our other sides. Okay? So let's find, I'm going to get rid of this. I'm going to get rid of this right here so we don't have any crazy stuff going on. So what we're going to do is we are going to circle one of our acute angles. It doesn't matter which one you pick. Let's just pick the one that they gave us, 54. And now let's find A. We're going to find A. Across from our angle is the opposite, and across from our 90-degree angle is the hypotenuse. So which trig function for SOH, CAH, TOA is opposite and hypotenuse? Okay, hopefully you recognize that it's sine. So we're going to set up our sine. So sine of 54 degrees is equal to opposite, which is A, over hypotenuse, which is 20. Okay? And then I'm going to do the same thing I've always done. I'm going to put it over 1. I'm going to cross multiply. A times 1 is A. Sine of 54 times 20. Sine of 54 degrees times 20. Okay, so our A is already by itself, so we're already good. Now we just have to go to our calculator, and we have to type in sine of 54 degrees, sine of 54, close your parentheses, times 20, and that will give you your missing side. So our missing side is 16.18. Okay, so A equals 16.18. So you go back up to the top, 16.18. 20 and 16 seem pretty reasonable. Okay. Now, I'm going to move this information over, and we're now going to set it up for our other problem. We're going to set it up for other problem. Okay, so I'm going to put a bar here. Now, once again, I'm going to erase what I have there. I'm going to erase everything that I have. Okay, we're still going to use 54, but now we need to find little c. So I'm going to circle, so I'm going to go across. This is still the hypotenuse, and c would be the one touching the theta, so we're going to use adjacent. Okay, so which trig function uses adjacent and hypotenuse? Okay, hopefully you recognize that that is cosine. So cosine of 54 degrees equals adjacent, which is c, over hypotenuse, which is 20. So cross multiply. C times 1 is c. Cosine of 54 times 20. And then you just type that in on your calculator. Cosine of 54 times 20. Move this over. So cosine of 54 times 20 is equal to 11.755. So C is equal to 11.755. So 76. And then you go up here, fill it in, 11.76. Now we have all of our answers. There's your 6 points for getting the problem correct. Okay? So what I want you to do, on your notes, there's an example 5, which is the same thing as we just did, solve the following triangle. And there's another word problem here. Make sure you do these or attempt to do these and bring them in with you the next day, and we're going to go over these in class. Okay, so I just gave you 2 problems. Do them in your notes, right on your sheet. Bring them back with you. Have a good day. This is probably going to be the longest video that we do in this section, and I will see you tomorrow.